Hi folks, I'm Matt Small, the Regional Science Liaison for EPA Region 9 here in San Francisco. And I'm going to give you a PFAS update today for the 2022 Tribal EPA Region 9 Annual Conference. It's a recorded presentation. If you have some questions, you need some more information, my email is here and you can just send me a message. Also, Diane Barton is going to be providing a presentation. Diane's with the Columbia River Intertribal Fish Commission, and just look for her presentation on the website, and she'll give you a little bit more information on her work, on her PFAS work with the National Tribal Toxics Council. You'll see here that I've got links throughout the presentation for more information. This is the general link for EPA PFAS information. And you can see we have two main documents that EPA has produced, the action plan, PFAS action plan, and the PFAS strategic roadmap. Well, let's start with what is PFAS? PFAS are per- and polyfluoroalkyl substances, and they are man-made chemicals that have been used in industry and consumer products since the 1940s. These PFAS chemicals are widespread, they're mobile in the environment, they can be bioaccumulative, meaning that they can accumulate in plants, animals, and in our bodies. They're toxic, highly toxic, and they don't break down quickly. You can see here a bulleted list of known sources of PFAS. One of the big ones is firefighting foam, aqueous film forming foam, that's been used at a number of airports around the country, both to extinguish fuel fires as well as for training, firefighting training. We've also seen AFFF used at a number of military bases. PFAS production and use in industry, of course, is a source, and incineration, landfills, wastewater effluent, and land application of biosolids, which can potentially be an issue for tribal lands, particularly if tribal lands have been receiving biosolids as a fertilizer from wastewater treatment plants in urban areas where there may be more PFAS present. Consumer products, cookware, food packaging, stain and water repellent fabrics, your carpets, your clothing, pizza boxes, food containers, Teflon pans, all of these things contain PFAS compounds. And the sources on tribal land can include all of these sources, and also in particular tribal lands may be impacted if there are PFAS in subsistence foods, plants and animals. We have detected PFAS in fish tissues in some parts of the country. We have detected PFAS in plants grown on lands where PFAS contaminated biosolids have been applied, and we've also detected PFAS in animals that have been grazed on some of those lands. So things to consider for your tribal lands. So let's go a little bit into the EPA PFAS strategic roadmap. It gives the EPA commitments for efforts between 2021 and 2024. We have a one-year progress report coming soon. The strategic approach that we've employed in this document is to consider the whole life cycle of PFAS, getting upstream of the problem. Rather than trying to react to contamination problems, we'd like to cut off the sources of PFAS and hold polluters accountable. Obviously, we're using science-based methods to do this and prioritizing disadvantaged communities. The goals for EPA in addressing PFAS are research, restrict, and remediate. Researching all aspects of PFAS and understanding ways to address PFAS, restricting PFAS from entering the environment, and remediating in cases where PFAS is already in the environment. We have a wide variety of research that's currently being conducted. We have EPA research into the areas shown on this slide, methods for detecting PFAS, drinking water treatment options, cleanup, and destruction disposal options. We're also collaborating with the Department of Defense and Department of Energy on PFAS research, primarily for sampling, analysis, and cleanup. Restricting PFAS in drinking water. We are working to restrict PFAS by drafting PFOS regulations. Those are expected by the end of the calendar year. We've also issued interim updated health advisory levels for PFOA, PFOS, Gen X, and PFBS. As you can see, these levels are quite low. In fact, the 0.004 ppt for PFOA is parts per trillion. And since it's 0.004 parts per trillion, that's actually parts per quadrillion, which is lower than the detection limit. The detection limit is at about 4 parts per trillion in general. So these chemicals are considered to be hazardous at very, very low concentrations, in some cases even lower than the concentrations we can detect. In setting these levels, we've also the federal government has worked to try and come up with ways to help people pay for the treatment that's going to be required when PFAS is present in drinking water systems. This includes the bipartisan infrastructure law funding, and that includes money to help pay for PFAS water treatment. We've developed a number of methods, EPA drinking water methods for 29 PFAS compounds, that's 537.1 and 533. So if you send your drinking water in for analysis, those are the methods they'll typically be using. We'll also be sampling for PFAS in the next unregulated contaminant monitoring rule sampling. That's the UCMR sampling, UCMR 5. That will begin in 2023, and we'll be sampling for a variety of PFAS during that sampling effort. We've also created a drinking water treatability database with treatment options to remove 37 PFAS compounds. The links are available on the slide. As I said, we're also working to restrict industrial PFAS sources. We have significant new use rules under TSCA that prohibit significant new uses of PFAS. We've added 172 new PFAS compounds to the toxic release inventory, and we're tracking potential releases around the country. We've removed PFAS-related compounds from pesticides. We've got a national PFAS testing strategy test order to help gather additional data to inform future regulatory efforts. We've got preliminary Plan 15 to help with revised effluent limitations and pretreatment standards. We're also addressing PFAS and NPDES permitting. And you can see the results of some of these efforts in the blood level monitoring that the CDC has been using. This graph shows blood levels of most common PFAS compounds in people in the US over time. This is from 1999 to 2000, all the way up to 2017, 2018 data. And you can see that concentrations have been falling as a result of these restrictions, both on the efforts on the part of EPA as well as efforts on the part of industry. Contaminated site cleanup is obviously an issue for PFAS because we do have a number of releases that have already occurred. And one of the big things we're doing in this area is we have proposed rulemaking to designate PFOA and PFOS as circular hazardous substances. That will give us additional enforcement capabilities to drive cleanups where PFOS and PFOA have been released. We've also issued draft aquatic life criteria, additional draft method 1633 to help analyze for 40 PFAS compounds in 8 different environmental media, and EPA interim guidance on destroying and disposing of certain PFAS and PFAS containing materials. And we've also added 5 PFAS chemicals to the list of regional screening and removal management levels that are typically used to evaluate cleanup sites. These, in fact, are the revised regional screening levels. You can see where what the concentrations are based on the criteria, the hazard quotient, and non-cancer values listed on this slide. These are the links where you can go and look at these levels and calculate them for your own facilities. PFAS destruction and disposal is one of the big issues that we're facing. Right now, we don't have a good way to dispose of or to destroy PFAS, and that's difficult when people are treating drinking water with granular activated carbon, reverse osmosis, and we have material that is then contaminated with PFAS. We have spent carbon and spent membranes from reverse osmosis, and we really don't have any way to dispose of those at this point. So we're trying to figure out how can we move forward with disposal. We're doing quite a bit of research to try and evaluate that, and some promising technologies are being developed through small business innovative research, EPA research, and external research. PFAS in air is something that we're really just starting to work on in more detail. We're modeling PFAS air emissions to understand deposition and chemistry. We're evaluating incineration and destruction efficiency for some of the more simple PFAS compounds. You can see our test incinerator here. ORD is we're testing incineration of firefighting foam. We're testing industrial fabric coating facilities, and we're looking at potential PFAS sources in air, production, disposal, and incineration. Enforcement. EPA enforcement strategy, really currently, since we don't have any regulations in place, we only have a health advisory in place. We rely first on state, tribal, and local authorities and use federal authorities as appropriate where those existing authorities are unavailable. We do have some regulations that we can fall back on, even though they don't mention PFAS specifically. We have the Safe Drinking Water Act, we have the Resource Conservation and Recovery Act, sections 3004, 3005, 3013, and TSCA, sections 5, 6, 7, and 8. So we can undertake enforcement should we need to, but we're looking at the upcoming MCLs and Circle of Hazardous Substance designation to give us stronger enforcement capabilities. And we're tracking PFAS through the ECHO PFAS analytical tools. This is and many of the graphs that you've seen in this presentation came from the PFAS analytical tools. We're bringing in a lot of the data from around the country into this tool, and it's available to EPA partners. Soon it will be available publicly, but it's already available to EPA partners. This is instructions for how you can get access to that tool to better understand and to view the data that we have available on PFAS. If you need help with that, my email is here, and here's the instructions on how to get in there. EPA Region 9 has been doing quite a bit of work to support states and tribes with PFAS issues. One of the big things we're doing right now is we're providing no-cost PFAS sampling for all regulated tribal drinking water facilities. You can contact Emmanuelle Rapicaboli, and she can give you more information on how you can have your water tested. We've also supported Arizona, California, Hawaii in their efforts to evaluate PFAS contamination in their states, as well as develop analytical methods and cleanup goals, screening levels. So there's links there for access to that data, depending upon which state borders your tribal lands. Thank you for your attention, and please feel free to contact me if you have any additional questions on PFAS. I'd be pleased to chat with you. Thank you.